Um, so, previous lecture we talked about different systems, Apache systems, which is used for processing uh, leave requests, leave data. For understanding how more detail, we talk about principles of Storm, Apache Storm. But now we have to talk about some queuing system and how it works. Actually, what does mean queue? Queue is some processing device or processing issue, and new requests come one by one to make some, so to do some job and something like this with this system. According to queuing systems, uh, with um, with some storage, and you can see such kind of queuing systems with two main principles. First principle is pool model. When server send information from producer send information to server, and then server push consumer request or push information for consumer. The queuing server, it's like you somewhere where some place where the store the requests or some elements stored while it's not processed. So it's queue server. According to pool model, how it works, first of all, it is good because consumers can efficiently control their own workload. Pool model. Pool model. Sorry. Pool model. It means that consumer takes requests from server, and so consumer ask request, and the server pool give as a answer the request, and then consumer process this request. So consumer can control the how many requests it is needed for processing. Second plus is that model allows you to group message into benches, and then so consumer can process requests from one of the bench. It depends on policy of processing. From other side, it can be for sure this system is has potential imbalance of load between different consumers. Also high delay in data processing because server waiting for consumer. Second one, kind of queuing system is push model. Push model is when you have queue server, you have group of producers, you have, no, actually, you can have more than one consumer, and even in this model. So lots of consumer can ask, in first model, lots of consumer can ask server about requests, and also divide branches between consumers. So it's first model. Second one, push model, when queuing server send push requests, push information for processing to consumers. Also, it gives us possibility to balance loading balance for the consumers. Actually, this question, according to queuing system, I mean, it's very very important question because when we have thousands or no, big amount of the requests for processing, we efficiency of QA server it has a main influence into efficiency of the whole system because managing of the request, management of the request is very necessary thing from one side, and it's very we can't work without it because of lots of thousands and thousands requests. So therefore, queuing system is very important. Also, push model allows to efficiency balancing distribution of messaging across consumers and less latency, good balancing. This system, but what minus is that this system have to use QS functionality by setting limits. What does it mean? Because if we always send, so we have to have uh, backlink from consumers according their load, because without this we can send too many requests for processing, and consumers the efficiency of the consumers will become lower because of its load, its overload. So we have to have QS functionality to control the overloading of consumers. And also typical message life cycle of querying system. How it first of all, so producer sent a message to servers save it, save or stored it. Then consumer fetch the elements on the server, and the server. What is the main idea of this server? We shouldn't lose any request, because of and therefore we talk about fetching. So it means that request on the servers, request is not dropped from the server before its server receive confirmation that this request was processed by consumer. So after successfully processing, the request is permanently removed from the server. So, but only after confirmation about this the processing of the request. So it's main idea from one side. From other side, we can no. So we should these principles is used in different systems or technology, like Kafka, on you see Rabbit QM works. So it's different kind of systems. Maybe it's the next part of our Do you have question according to lecturing, according to queuing system? Okay, you haven't. So we can, I recorded. Next part, the next part of our lecture today is we will talk about big data management and maybe a little bit about infrastructure organization. Maybe we will not. We will not. According to big data management, also. Oh, you see here this question also. It means that previous year we also talk about this on sixth lecture. Okay, so according to server queuing system, we understand. If you don't have question, we can continue. Apache Kafka. Actually, it's from one side, it's storage. From other side, it's a system who can process no, queuing system, queuing storage system. So fundamental difference between Kafka and queue is how messages are stored on broker and how they are consumed by consumers. What is the main idea? Main idea that that Kafka broker can Kafka broker doesn't delete messages. So doesn't delete the requests from data, and also same messages can be processed any number of times by different consumers. What it gives us? Why we need Kafka and not enough just why we use Kafka broker? Because of I think we talk about in our lecture in our course we talk about replication. What does mean replication? It means that big data, when we talk about big data, when we talk about lots of requests, we should be sure that any request will not be lost. And therefore, maybe I turn off camera. No, it's okay. Kafka propose us to replicate servers or no, so Kafka querying server in here it calls Kafka broker. So Kafka broker, it's not only one issue, it's a group of issues where different elements is make different works from one side and store it different information, store it the same information, but different consumers. No, it means just a minute. I will tell you step by step. First of all, as we talk about branches that we when all requests entered in to the QA server, this request can be range as как-то sorted into different branches or different patch. Patch, I think is called patch. Yes. Topic, registration topic. Okay. So messages in Kafka are organized and stored in different topics. Topics, it's like a group of queries. Also, each passions, what passions. Each topic consists one or more partitions. So it's elements who store one kind of request or few kind of requests. So it's some queues, some independent queues with elements from which has some kind. Then distribution makes it possible to scale the cluster horizontally. Clients can write and read messages from several brokers at the same time. What does it mean? It means that we have registration topics. These registration topics is replicated into three brokers. Each broker has these three brokers has the same positions, but different brokers has different main partition. So consumers ask about consumers process information from the main partition from the broker, and the other one is just replied. So they renew information from main partition. So we have leader partition. We have three brokers. We have in this example we have three partitions, and these partitions, each partition is replicated into three ones, and consumer to speak or to process requests from lead partition. According to how organized consumer. See, consumer is some processing element who so this is element who process the request from the brokers. So it can be different, such kind. For example, from one side, what does it mean that consumer? For example, it can be mail server group or stats server group. So different. So this consumer is element who process the elements of the some kind of the elements or each element kinds of elements. So we can see such scenario for consumer groups. One has consumer can have one processing elements who works with different petitions from registration topic, right? No, this example is possible. Second one, when one consumer speak with different branches or different petitions. So one consumer, one partition. And all, for example, if we will have four partitions and or three partitions, four consumers, one consumer will not have a job. So it is done for the fast processing, because for sure this process, this queuing system is organized for fast processing of the requests. Working on the fly. So from other side, we can speak, you can see different servers, different of consumer, so ML server or stat server, and it is possible when different consumers speaks with different positions and so on. So this kind of division of обов'язки. This can work also just in this case. Consumers 4 will be without work. This one it's okay, because one consumer you speak out or take requests from one partition, and it's okay. Also, you can add partition on fly. I remind you that partition, it is some kind of group of requests, some queue, kind of queue. It's partition when who receive requests from producer. Without restarting clients or brokers, it should be taken into account that data or the guarantee if you write message will not read. I mean that it means that this structure is very flexible because how it organized. Actually, I have to lots of systems works with a huge number of requests of data. Actually, a lot of nowadays computational systems, information system works with the data. And therefore, load balancing is very important question. And here we can see that these consumers can be added, for example, on flight or not, depends on depends on this our necessary. But what gives us this kind of division of positions? Actually, for example, if you have email server with one consumer, it means that this consumer, even if it has lots of resources, can be placed only with into other can be placed, or you can control its resources. And when you have huge application or application which is takes lots of requests, it not so flexible, scalable for the system. Other question, when you have a group of partitions, you have group of different consumers, and in this case you can for example place consumer 2 somewhere where you have more resources or less resources. So what we speak about this all time that we need instruments from one side have some application who process the request. From other side, we have hardware or so computational resources. And this question how to place virtual machines on the hardware or other things, how to place how to manage application from one side, request from other side, requests from other side. That means load balancing, and hardware infrastructure with its limits. Because as I told you, we need quite unlimited resources for processing high-loaded system. So we speak about high-loaded system, which should process as many requests as it needed. And here we can see this instruments for placement different consumers on different servers to process because for processing requests we need some computational resources, it's for sure. And therefore when we place this on different servers, we can we can easily more easy control the resource usage. You understand me, I hope. So it's consumer groups of the Kafka. According to consumer offset mechanism, it means that so what we can see on the server. We have topic, registrations, petitions, group of so it is the table with counting of the request. So why it is so for example consumer, so mail server are take for processing the requests, and this request is allocated offset, you see, allocated into one of the consumers. So but this querying server or broker server, this Kafka mechanism, they didn't they don't delete any requests. They don't delete any request. Therefore, it's just we collected in the table with some marks or and stored information who process, where process, and so on. So each petition have something like бегунок. So consumer you ask consumer process the request. A request is marked as marked the group who processed this one, and then server how to say this querying server receive commit from mail server mail server for this one. So server has requests has consumer takes this request, mark them as a that it is in processing, and then commit that this request after no was processed, and therefore we receive new one. Do you have question according to main principles of Kafka, Apache Kafka? We last how to say last lecture we somebody from you said that it is better to look through these technologies, how it works and so on. But actually, our core course is very short, and I just want to make some overview of the technology of even about some instruments for work with, which is used for high-loaded systems, and therefore we have not enough time for detailed description of the system. But main principles, main ideas of this system, I want to explain for maybe better understanding where it used, where you can use it, and how it works. Therefore, it's just main mechanisms of the elements. So next one, do you have question about Kafka?
No, it's
If
fine.
you don't have, let's go to Apache Storm. Apache Storm, it's for fast processing information, but not for as a queuing. It's not a queuing system. Main idea, it's maybe good explained is on this one. So, for example, it's maybe for parsing. Apache Storm is used for parsing of data flows which is received. For example, you have in entrance something like John said, write somewhere, tweet, hello everybody. And you can parse it. So you need some parsing of this incoming information, maybe for processing in the next step. You see a difference because there it was exactly. So when we talk about this petition, it was some already understandable information. So it's some block of information which can have to be processed. So it's before. So this Apache Storm is used before this Kafka. Maybe it will be better to replace these parts because you receive different information, and this information should be parsed into so divided into different blocks and for future processing these blocks. So spot for example, Apache Storm is system who consists from two elements. First element is spot, so it's catch information, And the next one is bold. Bold is used for parsing also. So, for example, Spot takes information from steaming API, Twitter steaming API, catch information from steaming API, and then send to the bot. For example, John, say everybody, hello everybody. So what we receive? What we receive in the outcome? What is the outcome of the bolt? Outcome of the bolt is, for example, parsing hello and everybody. So John say hello, and John say John say everybody. So this parsing is necessary for example, when you receive such kind of information, maybe you need to fix some no, actions. For example, we need information when John say hello, for example, or moment or some kind of tweet. So therefore, after both, after we receive this information, in that no, we can compare its result with some patterns, some filters. When we have no, when we look these patterns, comparing with patterns gives us some information about what we need. Depends on what we need. What is the interesting on this system? The main, you can see that on this picture, you can see that spot has, you can have, system can have lots of spots. Also, it calls tuple. Tuples, so tuples is sent from spot to bolt, and bolt no, parse information of the tuple. What we can see? We can see that, where is my, we can see that it's very simple ones from one side. From one other side, it can, no, different bolts can have different kind of parsing. And also different bolts can be placed. So this scaling or managing this system is, management of this system is quite easy because so spot its application, bolt its application, they are independent from each other from one side. From other side, they are from one side, from other side, they can be you can use they can be replaced, managed. So how to this system is flexible. So it can process huge amount of information. Oh, but it's quite, you can use, for example, different virtual machine. You can use different, I don't know, place it's this one's in different, no, I don't know, somewhere, in different data centers. Anyway, you can manage this system. This idea of this storm system is very flexible and it's very good for our high loaded technologies. No, maybe you will book. I will send lectures and you can look through. Okay, we have so main idea has that Apache Storm has spot and bolt, but for sure this is not enough for, it's not that's all. So we organize these spots and bolts into Apache Storm cluster, which is operated with master-slave principles, on master-slave principles, and consists following components. First, it's master process, master host, where executor is placed. So we it's no, it's our work path, worker path. From other side, it contains worker nodes, master host. Where is it? Master worker node. Master has master host, and what we have? We have supervisor who knows what process where should be processed. Да, so for processing task on the executor, we have possibility to manage the request. We have possibility to manage the request. Then Nimbus master node. What does it mean? Nimbus, it's some statistic. We will talk about this, about statistic. Nimbus collects statistic about how it works. So supervisor receives statistic from Nimbus and can manage elements. So no, can manage this worker process as it needed. So depends on what we need. And together, this Nimbus master, supervisor, worker nodes, worker processes, it's something like Storm cluster. And also, you see that supervisor know how works worker processes. Nimbus collect our inside information about work of subsystem and send it to supervisor. From other side, so it's all inside of the cluster. From other side, we have Zookeeper framework. It's also something like statistic or no, so some block who knows how it works all together. So not only one worker or one worker node, it knows how the Storm cluster works. All no, all whole system works together. So it is maybe it's, and that's all what I want to say about Apache Storm. But anyway, Apache Storm is used for fast parsing the request. So it's take some block of knowledge, or no block of data. It calls tuple. This tuples is sent into the bot who process, who make some parsing. So according to templates. So this system of processing organized into clusters where we add some elements, some like supervisor or Nimbus, which looking on the elements to be sure that there is enough resources, that there is enough all requests is processed as good and so on. So the different QS quality of service features. So it's how Apache Storm works. Do you have question about this? How many time? Okay. If you don't have question, I think you can. Yes, these elements is no, it's free. So it's open. You can use Apache Storm. You can use Apache Kafka for your project, and it's free. And for sure, you can try it. But when you try, when you try new technology from one side, you don't understand anything. From other side, you have to know how it works in general. And so it's how it works in general. I tell you on now on my lectures. Okay, we talk about how to we talk about big data or high load from side of so who uh, organize this load, how it is processing, and so on, so on. From other side, so it's from side of applications. From other side, we have to have infrastructure for this. How to organize infrastructure for processing high load. So for processing this high load system. So I think you know something and about containerization, about virtualization, but I will start to talk some words, and also we'll talk about some so different open source technologies for this virtual environment. So first of all, so difference between containerization and virtualization. Main difference is that container it's like a program, like application, but it has its own environment and it's independent on. So if applications inside of or just in your computer can no, it's not isolated as usual, but container it has its own servers, its own applications, and all this is packed into this container, and you have so it works application inside of the container works as like it's only this one, like it's alone on all over computer. So container runs on the same operation system as main one, doesn't virtualize hardware, what is very important, and contains only application and some operating system API for service running in user mode. According to virtual machine, it's exactly independent thing with some, it can be our other operational system with its own kernel, its own applications, servers. So it's independent one, and I think you know what does it mean. But why we talk about this now, and why it's necessary to know how it works because containers is very containers or virtual machines, it's very useful element for managing processing issues. So processing issues, I mean that some application for processing lots of requests, and therefore we can manage these elements. We can organize container which will be receive our request and process, or we can organize virtual machine, and in this virtual machine we will receive and answer, no, and process the request. So we can put into container or virtual machine consumer or partition or something else, and it's just like element of infrastructure. And when we speak about container, you can move container from one, for example, computer to another computer, and it will not lose something, lose not even information, not lose connection, or not lose. So because it works as independent things on this computer. Also, so we can migrate it from one computer hardware to another hardware and so on. And therefore, it's very interesting issue for organizing this flexibility, availability, blah 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 element. So this good idea of good managed high-loaded system should use some instruments for process, for good fast operation, and this fast operation is can be proposed by containerization technology or container technology or virtual machine technology. Okay, what else? Containerization. We will little bit. Okay. Maybe I think we will talk about containerization next time because we have few minutes for this. Do you have question to me? Okay, I
No,
can.
no.
If you pass the test, I can answer you what was your marks. Just a minute, I will open Tix. I can show you all marks, or you want to see say me and I will ask. Will be this correct to say marks to all of you? Okay, it's just a minute. 16 people. Who want to? Okay, you can say me. Okay. Oh, this one is better. Okay. You can see here your marks. It's maybe 4. So do you have any questions? If not, I think we can stop. It's enough for today. Thank you. Let's continue next Thursday. Okay?
Yeah. Yes. Thank you for the lecture. Have a good evening. Bye.
Can you repeat because
I said yes. Thank you for the lecture.
thank you. Thank you for
Yeah.
thank you. Okay.
Yeah.
See you. Bye bye.
Yeah. Bye.
Goodbye.